for the game. It's a rich thing.
The Big Bang Theory by Dr. Cosmonaut. Introduction. The Big Bang was the beginning of everything, time, space, and the building blocks of all the matter in the universe. The great cosmic clock began to tick some 13 billion years ago in a fireball so concentrated that matter and antimatter were created spontaneously out of energy. Before the Big Bang Theory. There was no before the Big Bang because time did not exist. Time and space have always been intimately linked in what Albert Einstein called a space-time continuum. Once the time came into being, space could start to expand. After the Big Bang. After its initial expansion, an event that is by itself often called the Big Bang, the universe cooled sufficiently to allow the formation of subatomic particles, and later atoms. Giant clouds of these primordial elements, mostly hydrogen, with some helium and lithium, later coalesced through gravity, forming early stars and galaxies, the descendants of which are visible today. Besides these primordial building materials, astronomers observed the gravitational effects of an unknown dark matter surrounding galaxies. Most of the gravitational potential in the universe seems to be in this form, and the Big Bang Theory and various observations indicate that this excess gravitational potential is not created by baryonic matter, such as normal atoms. Measurements of the redshifts of supernovae indicate that the expansion of the universe is accelerating, an observation attributed to dark energy's existence. Cooling of the Big. The universe continued to decrease in density and fall in temperature, hence the typical energy of each particle was decreasing. Symmetry-breaking phase transitions put the fundamental forces of physics and the parameters of elementary particles into their present form, with the electromagnetic force and weak nuclear force separating at about 10 to 12 seconds. After about 10 to 11 seconds, the picture becomes less speculative, since particle energies drop to values that can be attained in particle accelerators. At about 10 to 6 seconds, quarks and gluons combine to form baryons such as protons and neutrons. The small excess of quarks over antiquarks led to a small excess of baryons over antibaryons. The temperature was no longer high enough to create either new proton-antiproton or neutron-antineutron pairs. A mass annihilation immediately followed, leaving just 1 in 108 of the original matter particles and none of their antiparticles. A similar process happened at about 1 second for electrons and positrons. After these annihilations, the remaining protons, neutrons, and electrons were no longer moving relativistically and the energy density of the universe was dominated by photons. Galaxies formation. The matter is clumped together into galaxies, but the Big Bang produced only a fog of gas spread less uniformly across the cosmos. One of the great mysteries of astronomy is how this gas was pulled together, condensing into individual galaxies becoming beautiful spirals, with large reserves of gas.